Good day, viewers. Welcome to another additional mathematics presentation. So in this presentation, we are answering question 5, and this is a question coming from circular measure. So this question came in additional mathematics paper 1 for 2024 for GCE. The question reads, in the diagram OSC, so here we have OSC, which is the sector with the center O right here. Then we have the radius, which is 5 centimeter from O to A. The radius is 5. So OF we have 3 and the FA we have 2. So when we combine 2 plus 3, we are going to have the radius, which is 5. So here we are told that AF is equal to CD. So AF we have 2 centimeter, even on CD we have 2 centimeter. Then we are told that DE is also equal to EF. Okay, so DE is equal to 2, EF is equal to 2. So DF together, the total is 4 once we add 2 plus 2. Then here I told that OB intersect DF at point E, forming an angle of 90 degrees right here at this point E. So we have our question here, find the value of theta in radians, and this question was carrying 3 marks. So to find the value of theta in radians, this one is simple, because you can, when you look at this shape that we have where theta is, this is the entire angle for theta that they want us to calculate. Now, if you want, you can consider these 2 shapes. If you want, you can consider those 2 shapes. Okay, so this one you can say this is O and this is F. Okay, then this is D. We have considered this entire triangle if you want. So you can notice that here we have been told that FAF is equal to DC. So meaning that OD and OF, these are equal. Okay, so if here you have a 3, it means that even here there is a 3. Then you need to find this theta right here. You can consider this. Then FD, we said we need to add 2 plus 2, which is a 4. So you can consider this isosceles what? Triangle. Okay, to find the theta. And to find the theta, you can use the cosine rule. If you don't want that, you can just consider this part only, where we have now this theta. But remember, this theta that we are finding for this part is not the entire angle here. So once you consider this, here it will be O, here we'll consider it A, and here are going to have F. So you are going to have the 3 here, 3 centimeter, and you are going to have the 2 centimeter right here. So if you consider this right angle triangle, we are going to use one of the trigonometric ratios to find the theta. So the side where the theta is pointing, this is the opposite. Okay, so this is the opposite. And definitely this longest side of the right angle triangle, this is the hypotenuse. So we have the opposite and the hypotenuse. So the trig ratio that you are going to use is sine theta, which is equal to opposite over hypotenuse. So here you can say sine theta is equal to, so the opposite is 2 over the hypotenuse is what? 3. So from there, what are we going to do? So from there, we are just going to find the inverse, where we say theta is equal to, because we are finding theta, which will be sine inverse of 2 over 3. So remember to put your calculator in radians, because the question did specify that the value of theta should be in radians. So if you press on your calculator shift, and then you are going to have sine inverse of 2 over 3. The theta you are going to get will be this value, which will be 0.729. Okay, then 727, then 656, then 23. Okay, so we can now say therefore, now remember the theta that we are finding, this is just the theta for this part right here. So if we find the entire theta, meaning that this is an isosceles triangle like we said, so the theta which is here will be equal to the theta which is right there. So this value that we have found, okay, this value that you have found, we can multiply it by 2. Okay, we can multiply it by 2, so times 2. So we say theta is equal to, if you multiply it by 2, which will be 1.459, then we have 455. Okay, then we have 212, then 46. So we can now say, therefore, theta is equal to 1.46 rad, because the angle should be in radians. So this is the value of theta. Okay, so remember, even if you use the other method, you consider this triangle that we came up with, this one right here, you use the cosine rule to find the value of theta, you are still going to get the same answer, which is 1.46 rad. Okay, then we come to our question B right here. So question B says, find the length of an arc AC. So we need to find the length of this arc AC. So how do we find the length of that arc AC? So we are going to say arc length, okay, arc length is equal to radius times the theta. So from here, the radius, we know what is the radius from O to A, it's 5, as we have been told there. So get the 5, then times the theta that you have found. This entire theta, you have said this is 1.46 rad. That's what you have found. So where there is theta, you just put 1.46. So from there now, once we multiply on our calculator there, we say 5 times 1.46. This will give us something like 7.3. Don't forget the units, 7.3 centimeter. So this is the value of the arc length. So thank you so much, everybody. We've come to the end of our short presentation. So please, for the purpose of learning, try even to find this theta using the cosine rule. Since you have these three sides, the values, it will give you the same. Okay, so thank you so much, everybody. Once again, bye bye.